Hi students, this is the part 2 session of lesson sound. Today we are going to discuss about the topic that is reflection of sound. The reflection of sound is same as reflection of light. How the light reflects? We have the law of light, law of reflection of light, that is the angle of incidence is equal to the angle of reflection. Like that here, the angle of reflected sound is equal to the angle of incident sound is equal to the angle of reflected sound. Here you can see this picture, reflection of sound. This is the incident sound. Okay, the sound produced by the object here from here, and it will incident on some other object. Okay, for example, we have taken the wall. Okay, when it go and hit the wall, it will reflect. The sound will reflect. The angle of incident sound is equal to the angle of reflected sound. So this is the normal drawn to the both the incident ray and reflected sound. Okay. Same as the law of reflection of light, how it is there, same as here the follows the reflection of sound. The angle of incident sound wave is equal to the angle of incident reflected ray. So this is how we compare the law of light and law of sound. Okay. So that is why they are given here to they have given in this panel that only the angle of incidence is equal to the angle of reflected ray and the normal ray drawn. They have taken the ball as a surface area. So they have next they have given the topic that is echo. So echo is the reflected. It will bounce back to the sound will bounce back when it hits this any wall or any surface area. Okay. So if we shoot or clap near a suitable reflected object such as tall building or a mountain, we will hear the same sound again a little later. Okay. So if we clap, so whenever we stand in front of a big mountains or big walls, if we clap, the sound will reflect after some time. Okay. This sound which we hear is called an echo. This sound is known as echo. So whenever we clap, we are hearing once again that same sound after some time. So that sound is known as echo. The sensation of sound persists in our brain for about 0.1 second. Only 0.1 second our brain will persist. The sound. To hear a distinct echo, the time interval between the original sound and the reflected must be at least 0.1 second. If you want to hear the echo, the sound which comes after 0.1 seconds, then only we can hear the distinct sound. Otherwise, we can't hear the other sound. If we take the speed of sound is 344 meter per second at a given temperature, say at 22 degrees Celsius in air, the sound must be go to the obstacle and reach the back to the air in the listener on reflection of air 0.1 second. Hence the total distance covered by the round from the point of generation to the reflected surface back should be at least 34.4 meter. So whenever the echo will create means at least the surface area or the mountain and the creating object, the disturbance creating object should be at the distance of 34.4 meter. Then only the echo will create. Otherwise, the echo will not form. Okay. Thus, for hearing distinct echoes, the minimum distance of the obstacle from the surface of the sound must be half of this distance, that is 17.2. So, if the wall is about 17.2, the sound will reach for 17.2 meter and once again it should come back to us. Then only it will become 34.4 meters. Okay. So, this distance will change with the temperature of air. Echoes may be here more than one due to successive of multiple reflection. Multiple reflection also takes place. If two surfaces, if two walls are there, if we are standing in between the two walls, if we clap, then the sound will travel in all the direction and they will once again come back. Okay, this will happen due to the two walls present in between the 17.2 meters. Then it will create a lot of echoes. So echo will form after minimum. If we want to create echoes, then the minimum distance should be 17.2 meter from the sound creating object to the wall or any other bigger surface areas. Okay. So revibration. The sound creating a big orb which persists by repeating reflections until it is reduced to a value where it is no longer audible. The repeated reflection of that results in this persistence of sound is called revibration. Revibration means there is no time interval, continuously it will fall. Okay. So if the time interval is 0.1 second, then it will create echo. If the time interval is not there, then it is said to be as revibration. Okay. In the auditorium or in the picture halls, we are going to see the reverberations. For observing the sound, they are the theaters and the auditorium rooms were created by the sound absorbent materials like fiber wood, rough plasters they have made, so that the reverberation will not take place. The disturbance will not come by reverberation. So that the theaters and the auditorium walls were made by the sound absorbent walls like rough plasters they will do, otherwise they will cover by the fiber board also, so that the reverberation will not take place in the theaters and in auditorium. Uses of multiple reflection of sound. So wherever we use the multiple reflection of sound means megaphones or in loud phones or horns, musical instruments such as trumpets and shehnais, we are using this multiple reflection of sound. Are all designed to send sound in a particular direction without spreading it in all directions. They have given in particular direction, in that direction only the sound will travel. For example, they have given in the figure, you can see here megaphone, this is the horn. They will give the direction for the sound for traveling particular direction. Okay. In these instruments, a tube followed by a conical opening reflects some successfully to guide most of the sound waves from source in the forward direction towards the audience. They will give the particular direction, and it has a conical flask-like structure which is having an opening. Through that, the sound will be given the direction so that the audience can clearly hear the sound. It will not travel in all the direction. Stethoscope is a medical instrument which is used for listening to sounds produced within the body, chiefly in the heart or lungs. In stethoscopes, the sound of the patient's heartbeat reaches the doctor's ears by multiple reflection of sound as shown in the figure. In the stethoscope also we are using the multiple reflection of sound, so we can hear this heartbeat of sound. So different sounds which are produced in the body we can hear easily through the help of stethoscope, which is based on the physics, that is multiple reflection of sound. Stethoscope, how it will work means, due to the multiple reflection of sound, we are hearing the sound of heartbeat. Okay. Generally, ceilings of concrete halls, conference halls and cinema halls are covered so that sound of reflection reaches all corners of the hall as shown in the figure. So like this they have given the multiple reflections you can see here from one source of sound. So the sound will go in this direction, it will be turned, it will go in the parallel direction. Like the same, the sound waves will go in the all the directions, so that in theaters or in auditorium, all the audience can hear the sound in clearly way. Okay. So range of hearing, the audible range of sound for human beings extend from about 20 Hz to 20,000 Hz. So 1 Hz is equal to 1 cycle. 1 cycle of wave is known as 1 Hz. Okay. Children under the age of 5 and some animals such as dogs can hear 25 kHz. That is 1 kHz is equal to 1000 Hz. As people grow older, their ears become less sensitive. Okay. As the people grow, their ears become less sensitive and their eyes also become less sensitive. To higher frequencies, sounds of frequencies below 20 Hz are called infrasonic sounds. Sounds of below 20 Hz they are known as infrasonic sounds. So if we could hear infrared sound, we could hear the vibration of pendulum just as we hear the vibration of the wings of a bee. So rhinoceros communicate using infrasound of frequency as low as 5 Hz. Rhinoceros, when the time of rhinoceros, they will communicate through the sound of below the 5 Hz. Okay. Whales and elephants produce sound in the infrasound range. It is observed by some animals get disturbed before earthquakes. Earthquakes were produced low frequency infrared lowest sounds, so that they will get alerted. So whenever the natural disaster takes place like earthquake or tsunami, they will get alert before only. When compared to the human beings, animals will get alert before only. Why? Because they can hear the sound. So very less frequency also. The sound frequency higher than 20 kilohertz are called ultrasonic sounds. Okay. So below 20 kilohertz they are known as infrasonic, and above 20 kilohertz they are known as ultrasounds. Ultrasound is produced by dolphins, bats, and other animals also. Most of certain families have very sensitive hearing equipments. These moths can hear the high frequencies of the bat and known when a bat is flying nearby and are able to escape capture. Rats also play games by producing ultrasound. So many animals also produce the ultrasounds, so like rats, bats, they will create the ultrasounds. Nowadays they are using the ultrasounds in medical field also. I think they have given here applications of ultrasound. So ultrasound, applications of ultrasound. Ultrasounds are high frequency waves. Ultrasounds are high frequency waves. Ultrasounds are able to travel along well-defined paths even in presence of obstacles also they will travel. In the presence of obstacles also they will travel from one end to the another end. Ultrasounds are used extensively in industries and for medical purposes also. Ultrasounds are used in industries and medical purposes also. Ultrasound is generally used to clean parts located in hard to reach places. For example, spiral tube, odd-shaped parts, electronic components, etc. Ultrasounds were used for cleaning the areas in which we can't go through that area. For example, spiral-shaped tubes in that we can't go, so that using the ultrasounds we can clean the spiral-shaped tube also. Odd-shaped parts, so we can't put the hands in that odd-shaped parts, so that through the ultrasounds we can clean the different parts also. In the electric components also cleaned by using the UV rays. So objects to be cleaned are placed in a cleaning solution and ultrasonic waves are sent into the solution. Due to the high frequencies, the particles of dust, grease and dirt get detached and drop out. So due to the high frequencies, the dust or the dirt or the grease which are present in that area, they will be cleaned out or washed out. The object thus get thoroughly clean. Ultrasounds can be used to detect cracks and flaws in metal blocks. Metallic components are generally used in construction of big structures like buildings, bridge, mechanics, and also scientific equipment. These ultrasounds are used for detecting wherever the metal box has been created, if any metal box is inside it, if it has any cracks, for detecting that crack they are using the ultrasounds. Okay, for constructing in the buildings, bridges or machines they are using this ultrasounds. The cracks or holes inside the metal box which are invisible from outside reduces the strength of the structure. The cracks which are present in the metal box, they will reduce the strength of the metallic blocks. So using ultrasonic waves are allowed to pass through the metallic block, and detectors are used to detect the transmitted waves. If there is even a small defect also, the ultrasound gets reflected back, indicating the presence of the flaw or defect. As shown in the figure, they have given here figure. They will pass through like this ultrasounds or ultrasonic waves. If they have, this is the metal block. If you have any crack in the middle portion, then the ultrasound will come back from that crack. From where it will come back, we can find out the crack and we can conclude that this metal block is defected piece, and we can't use in the big constructions like building, bridges, so any machinery parts. So like that we can avoid the disaster by using this ultrasonic waves also. Ordinary sound of longer wavelengths cannot be used for such purpose, as it will bend around the corners of the defective locations and enter the detectors. They are very strong waves. If the object is very poor, then that will be get vanished. So we can't use in the less strength objects. We can use this ultrasonics in metallic objects only. Ultrasonic waves are made to reflect from various parts of the heart and form the images of the heart. This technique is called echocardiography. Echocardiography means by passing the ultrasonic waves, we can capture the picture of heart which is present inside our body. We can capture the picture of heart by the help of this ultrasonic wave. If any passage or if any veins or arteries are blocked, then we can easily find out through this ultrasonic wave, which is known as, this technology is known as echocardiography. Ultrasound scanner is an instrument which uses ultrasonic wave for getting images of internal organs of human body. A doctor may image the patient organs such as liver, gallbladder, uterus, kidney, etc. It helps the doctor to detect the abnormalities such as stones in the kidney or gallbladder or tumors in different organs. This is the technique. The ultrasonic waves travel through the tissues of the body and get reflected from the region where there is a change of tissue density. So we can find out the kidney tissues, or else we can find out the tumors which are present in our body, or if there are any stones in gallbladder, we can find out through the help of this ultrasonic waves. So electrical signals generate the image of organs. These images are then displayed on the monitor or printed on the film. This technique is called ultrasonography. So ultrasonography means they will get the pictures and we can print out that picture. That is known as ultrasonography. Okay, any organ picture. Ultrasonography is also used for examination of fetus during the pregnancy to detect congenital defects and growth abnormalities. During the pregnancy, we can use this ultrasonography for taking the picture of the uterus or this one fetus, for seeing the defects or abnormalities which are present in the fetus. Also, we can represent or we can detect by using the ultrasonic waves. Ultrasounds may be employed to break small stones found in the kidneys and fine grains. These grains later get flushed out with the urine. So ultrasounds, using the ultrasounds, we are cracking the stones which are present in the kidneys or gallbladder. After the cracking that stones, they will pass through the urine. Okay. Ultrasounds, we are using the ultrasounds. Ultrasound sent by the transmitter and received by the detector in the boats and in the ships for detecting the depth of sea. We are using the ultrasounds. So like this, they will send the ultrasound, they will reflect back, so that they will detect the detector and transmitters on the seabed water surface, so that we can detect the depth of the sea also by using the ultrasounds. 2D, why we will use means two distances are there here. One distance we will set and another one distance which we are getting. So that's why we are using 2D here. 2D into V into T, velocity into time. Okay, echo ranging, we can say this one as echo ranging. Ranging means for measuring the distance of seabed, we say that one as echo ranging also. The sonar, the technique used to detect the depth of the sea. That instrument is known as sonar. Okay. Sound, navigation and ranking. That is a sonar full form we are going to see. So they have given one example also. Structure of human ear. How do we hear? We are able to hear with the help of extremely sensitive device called the ear. Ear is a one type of sensor through which we can hear the sound, different sounds. It allows us to convert pressure, vibration in the air with audible frequency with electrical signals through that travels in the brain via the auditory nerve. The auditory axis of human ear is discussed below. So this is the diagram of human ear. We have this is the outer ear. This part is outer ear, middle ear, and inner ear. Okay. So this is known as inner, hammer, anvil. This is anvil, and this one is stirrup, over window, auditory nerve, cochlea. Eardrum, we can say this one as eardrum, auditory canal, and this is the tube or auditory nerve here, we can say anterior tube. The outer ear is called as pinna. It collects the sound from the surroundings. The collector The collector sound passes through the auditory canal. The end of the auditory canal there is a thin membrane called the eardrum or membrane. When a compression of the medium reaches the eardrum, the pressure of the outside of the membrane increases and the force of the eardrum inward. Similarly, eardrums move outward when the refraction reaches it. In this way, the eardrum vibrates. Due to the vibration of the eardrum, the sound wave get inserted or get inside the ear. The vibration are amplified several times by three bones. There are three bones in the ear. They are hammer, angle, and stirrup. These are the three bones in which sound is amplified several times. In the middle ear, the middle ear transmits the amplified pressure by variations received from the sound waves to the inner ear. They will amplify and they will send the sound to the inner ear. In the inner ear, the pressure variations are tuned into electrical signals. In the inner ear, the sound were converted into electrical signals by the cochlea. These electrical signals are sent to the brain via auditory nerve, and the brain interprets them as sound. So the electrical signals are sent to the brain, and the brain will interpret the sound, and they will send the information to the different organs. So this is what about the sound lesson. You can go through these points, and I will send the notes for this lesson in the WhatsApp group also. If you have any doubts, then you can comment in the comment box. We will give the suggestions. Like this, the bat also creates the ultrasonic sound, and they will detect the mediators also. Okay. So see you in the next class. Take care. Have a nice day.